The Fibonacci sequence, one of those things that turns up everywhere. Nature, art, finance, you name it, and there's probably a Fibonacci connection. But in programming, it's also a great way to watch your computer suffer. Title 1. The Fibonacci sequence, when math meets computational horrors on screen text. The Fibonacci sequence, when math meets computational horror. Mathematically, Fibonacci is simple. Start with 0 and 1. Each number after that is the sum of the two before it. The sequence 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on, forever. In theory, calculating the nth of Fibonacci number is straightforward. In practice, doing it poorly can make your computer weep. A common approach is recursion. Define a function that calls itself. Compute f of n-1 and f of n-2, then add them. Repeat until reaching f of 0 and f of 1. Sounds elegant, right? Wrong. It's a computational catastrophe. Every call spawns 2 more calls, leading to an exponential explosion. By the time f of 50 is computed, your machine has repeated millions of calculations. Enter dynamic programming, our savior. We solve Fibonacci once and store the results instead of mindlessly recalculating them. 2 approaches. Memoization, the top-down approach where we store results in a table. If a number has been calculated before, reuse it. And the bottom-up approach where we start from f of 0 and f of 1, iteratively building up the sequence, keeping only the last 2 numbers in memory. The bottom-up approach ditches recursion and loops instead. First, store computed Fibonacci numbers in an array, then iterate from 2 to n, calculating each step once. No redundant calls, no wasted computations. This reduces execution time to O of n, a dramatic improvement, even better. We refine it further. Instead of an entire array, we store just the last 2 numbers, cutting space complexity to O of 1. Cut to a smug programmer enjoying a smooth Fibonacci calculation. Beyond coding, Fibonacci numbers love the golden ratio. Approximately 1.618. Divide f of 100 by f of 99, and the result is nearly identical to the golden ratio. This connection appears everywhere. Spiral galaxies, pine cones, even financial markets. Cut to a montage of Fibonacci spirals in nature, stock charts, and architectural designs. The Fibonacci sequence may be elementary, but it's a perfect example of dynamic programming in action. What starts as an inefficient recursive mess becomes a structured, optimized process. And that, dear viewers, is the lesson. Computation isn't just about getting the right answer, it's about getting it efficiently. I am your guide, Antonio Klein. May the pseudo powers be always with you.